Hello Finxters. So today we're going to be looking at method resolution order, or MRO, in Python. And this is to do with Python classes and inheritance. And the topics we're going to cover in this video will introduce you to Python's method resolution order for classes and those rules that underpin that method resolution order. We'll look at three attributes that assist us to better understand how MRO works. And we'll write some code that shows how it actually works in practice. And we'll look at some errors that could arise if we were coding and we had no knowledge of MRO. So what is the method resolution order? It's used where we have one class that inherits attributes or methods from a parent. And it's quite important in the case of complex situations where you have multiple parents and grandparents and some quite complex multi-level and multiple inheritance issues, because if you didn't have it, it would cause chaos, or could cause chaos, in what gets returned to you. So it describes the order of search that Python follows, and it follows two prescribed rules that we will look at very shortly. And it prevents, as I said, attributes or methods being returned that were not as intended. So the three attributes we'll look at today. One is the bases attribute, and that returns to you the base classes from which a class inherits. So it'll return the parent classes for that class. The Python object class, and this is the superclass, if you like. That's the class that is built into Python that if a class has no other inheritance, it will actually have an inheritance from the Python object class, and we will show that shortly. And then we have the _MRO that returns the method resolution order starting from the current class you've called it against. And of course, when you call the MRO, the very final class that you see will be the Python object class. So we're going to look at all those in the code examples very shortly. So the two rules that I spoke about for method resolution order. The first is that children will precede their parents in the sort process. And the second is that when a child class inherits from multiple parent and grandparent classes, the search order follows the order specified in the bases attribute. And we spoke about bases just now. I'll show you in a second in the coding just what that returns. So let's go and do some coding. So in our first bit of code, this is the multi-level inheritance that we'll be using. So we will have two grandparent classes that flow to a parent and then down to a child. And you'll see that in the code, which I'll switch to right now. And here is the code. So we looked at the block diagram. This is it in code form. So we have two grandparent classes. One is stock, the other is warehouse. Both of those flow to a parent, which is produce. And then from produce, we drop down to the child, which is fruit. So block diagram and the code align. And we're going to show you first the bases, the _bases, _, and what that returns. And we'll call it on stock first because that'll allow me to show you the object superclass within Python. So let's do that now. And there you are. So just here you can see class object. So there is nothing else that stock inherits. You can see here that we have the close bracket notation and nothing in between. So there are no parents or grandparents for stock. So stock pulls anything that's required for its class from the Python inbuilt object class or superclass. Now let's have a look at what happens when we do this with warehouse. You should see obviously a similar thing. Warehouse again has no inheritance there. And now you have two class object, because we've called it against stock and warehouse. So that's as you'd expect. Now let's drop further down the family tree and we'll produce the double underscore bases for produce. And you can see there that produce has stock and warehouse as its parents. So let's just make that happen. And there you can see that the first order of search would be going up to stock, and then it would be going across to warehouse. So this is the bases flow that we were talking about, that produce inherits. And this is the flow that the MRO or method resolution order will follow. So let's now just drop down to the child, which is fruit. And once again, you'll see a perfectly logical return, which is produce. So we can see that fruit, we go up to produce, from produce we go to stock, and then we go to warehouse. And now if we pull it all together and show the MRO or method resolution order for fruit, that should align with those double underscore basis returns that we've just seen. So let's do that. And there you see we start with fruit. So we have class main fruit, then we have produce, so there's produce, then we have stock, there's stock, then we have warehouse, and then finally obviously object. So that's the method resolution order that Python will follow when you call attributes or methods on fruit, an object fruit. It will actually go searching in that hierarchy, in that order, until it finds either those methods or attributes, and then return what it is that you're asking for. So that's quite a simple situation. And I'll just return to the block diagram now just to refresh your memory as to what that looks like. So we had stock, warehouse, we had produce, and then we had fruit. And so we know that if we call bases, double underscore basis on fruit, it will search in fruit, it will then go to produce, then it will go up to stock, and then it will come across to warehouse. So what about a slightly more complex model? So in this model, the diamond model, we have a grandparent, we have two parents, and we have a child. So of course there's a number of ways that Python can choose to search this. Let's have a look at this in code. So the diamond model is a bit more ambiguous. Which path will it take? So we still have stock at the top, and inside stock I've put a method called label. And it will, if you were to call the stock label, it will print generic stock label. Then we have those two corners of the diamond. We have loose cans, which has stock as a parent, and we have box cans, which has stock as a parent. And both of those have a method called label, one of which says label for loose canned goods, the other says label for a box of canned goods. And then both of those flow down to the bottom of the diamond, which is canned fish. And you can see it's called both of those as parents, and I've put nothing in canned fish. And let's just instantiate that now with sardines. So we're going to call sardines, and then we're going to call label. So what you can see here, we've instantiated sardines and we've called label, and here it's returned a label for a box of canned goods. And that's fine, that's what we wanted. We expected to get that because that's what we're dealing with. But what if I'd wanted a label for loose canned goods, not a box of canned goods? And of course, this is not a perfect situation because you wouldn't want to have methods with all the same names to cause that degree of ambiguity. But we can deal with that in Python with the MRO. So let's just have a look at now, if we did double underscore bases on canned fish, that will tell you the search order that Python's going to take. So the first one will be box cans. So if we call label and it finds label in box cans, that will be the one it will print. If it doesn't find it in box cans, it'll go across to loose cans and it'll have a look and see if there's label there. And you can see how this might be difficult, because if someone changes a method or a name of a method, you could get some really strange things coming out. So it's very important to understand how bases and MRO work. And then finally, if we print the MRO, there you can see the full flow. So it starts off at canned fish, goes up to box cans, moves across to loose cans, and then it goes up to stock, and then finally class object. Now let's just go back to that block diagram and discuss that for a second. So why wouldn't Python go here from canned fish, go up to boxed cans, then go up to stock, go up to object, then come back to loose cans, and then go back to stock, and then go up to object again? And of course, we've spoken about the two rules that we use in Python, which is that you cannot have, the child will always have precedent. So you cannot have a grandparent or a parent ahead of a child. And of course, in this situation, you would have that. You'd have canned fish, box cans, stock, object, and then you're coming back to loose cans, stock, object. It just won't work, and it will actually defy the rules of MRO. So in this case, it goes from here to here, looks across to there, finally up to there, and then it ends up at object with the Python inbuilt class. So let's look at a slightly more difficult problem now, and one that will cause us an error. So continuing on the shop theme, we will have some code that has a supplier class. Then that flows to the shop warehouse, and within the shop warehouse there's a dispatch department, and then they can dispatch out to the shelves. But also we have a distributor who not only sends to the shop warehouse, they can also directly load the shelves on our behalf. So that's a true representation of what it looks like in the shop. Is it going to work? Let's have a look. And here's the code that represents that block diagram. So we have the supplier at the top. We also have the distributor that was sitting out to the right at the top, and the distributor has a method in there for printing a label. That then comes down to a shop warehouse, which has supplier and distributor as its parents. It then flows from shop warehouse down to shop dispatch, which obviously has shop warehouse as its parent, and then down to shelf, which has distributor and shop dispatch. And those were those arrows that went off to the side, where one went up to distributor and then the other went straight up to dispatch. And let's try and instantiate an object, we'll just call it A4, using class shelf, and see what happens here. And notice that we get an error. And the error says, type error, cannot create a consistent method resolution order for bases, distributor, shop dispatch. And of course this is as we discussed. So let's just go back to the block diagram, and it's possibly a little more clear. So what you're asking Python to do is instantiate an object, and it's looking and it's finding shop dispatch, that's good, but then it's finding distributor as well, and that's fine, but that's a great grandparent sitting in the great grandparent level, and you, as we've seen in the rules, you just can't have that before a child. So it can't go up to here and then back to here and then up to here and then possibly over to there and then back to here and up to there. It just doesn't work. And so Python will just throw a type error, and you need to try and work out what the problem is. Now, we could be clever and just say, I know, what we'll do is we'll just take this out of here, and we'll drop it in there, and problem solved. So it'll look at shop dispatch first, and everything will be fine. And in a way, you're right. It'll instantiate the object. We didn't get an error code this time, but you're leaving a bit of a ticking time bomb there. and it's an untidy piece of code. And everything in distributor, we'll just go back to that block diagram again. Everything in distributor is accessible to us via shop warehouse. So we can access all that through the normal hierarchy. We don't need this link here. So the way we solve that is we get rid of that leg. So let's do that in the code. So let's delete distributor entirely. And we'll once again call that. So there you are, no error message. And now what we'll do is we'll call that label definition, which is up in distributor, just to prove that it's going to find it. So all the way at the top there, we're going to call label from an object we've instantiated down here. And that should return the words that we need to see, distributor label. So there was no need for that other leg, but it's an important thing to understand that if you didn't know MRO in Python, you could end up making lots of errors like that, which would have you scratching your head. And these are very simple examples, but if you can imagine a very, very complex inheritance structure within some code, it could waste a whole lot of time. And then finally, let's just look at the MRO for this. And there you are with, let me open that up a bit so you can see it. So we start off with shelf, which is the lowest one. We move to shop dispatch, up to shop warehouse, move up to supply, across to distributor, and then finally class object. So it's all available to us. We didn't need that other link, and it was only going to cause us trouble. Even if we swap those two around so the basis flow was different, it could potentially cause us trouble in the future. It was unnecessary. So let's just go back to the presentation. So in summary, today we introduced Python's method resolution order for classes. We introduced those two rules underpinning the method resolution order. We looked at three attributes that assisted us to better understand MRO, and we wrote code that shows how MRO works in practice. We also looked at how errors can arise if you're not aware of MRO, how it works, and how to access that flow using either the __ MRO notation or the __ basis notation. So that's it for today. Thank you very much for listening. I hope that was helpful, and I'll look forward to seeing you in the next video. Goodbye.